Now that we've learned how to solve rational equations, the next thing is to learn how to graph rational equations. This is rational because it looks like a fraction. And we're going to graph its transformations. That means, just like we've done before, moving it left, right, up, down, stretch it, shrink it, and reflect it. So, how do I know what this graph is going to look like? Well, I've used an Excel spreadsheet, and so I've typed some numbers into my Excel spreadsheet and figured out what 1 over x is going to equal to. And I put it in decimal form to make it easier to graph. And so 1 over negative 10 would be this decimal. 1 over negative 9, 1 over negative 8. And so you can see that the decimals as we go this way are getting smaller and smaller. And I did the same thing with my positive numbers. I typed 1 over x. Now, 1 over 0 is not possible because you cannot have a 0 in the denominator. And 1 over 1, 1 over 2, 1 over 3. And I figured out the decimals because it's going to be easier to graph the decimals. These are not on your worksheets, by the way. And so now I'm taking those points, 1 over 1, 1 over 2, 1 over 3, 1 over 4, and those are getting closer and closer and closer to 0. Matter of fact, they get so close I cannot even write them here on my board. So this is going to get closer and closer and closer to 0. And so that was graphing these points right here. So graphing these points on this side. So this would be taking the points on that Excel spreadsheet and putting them on my graph, and this is going to get closer and closer and closer and closer to 0. But is it ever going to actually get to 0? If I put 1 over 100, it gets very, very small. 1 over 1,000, 1 over 10,000. It gets very, very, very small, but it doesn't actually ever get all the way to 0. So it's going to get closer and closer and closer to 0, but it's never going to actually touch 0. And that's what we call an asymptote. And we represent our asymptote. I'm making a dotted line in here. Might show up a little bit better if I made it with a highlighter. This is called an asymptote. It's going to get closer and closer to 0, but it's never going to actually touch 0. This is a horizontal asymptote, and so for this horizontal asymptote, the equation for that is going to cost the y-axis, so the equation for that asymptote is y equals 0. But what happens in between here? What's happening in this part of the graph? Well, in order to find out, I am going to have to graph some more points. I'm going to have to graph some points that are less than 1. And so if I graph 1 over 0.8, the way I got this number is I used an Excel spreadsheet, and I put 1 over 0.8 in my spreadsheet, 1 over 0.7 in my spreadsheet, and you can see as I do this, these numbers get bigger and bigger and bigger. And so what's going to happen on my graph over here is 0.8, and so let me get my points again. 0.5, I'm trying to find some that are going to be easy to graph. And so this is going to be at 2, and this is going to get closer and closer and closer. It should not even curve out like that. This is going to curve closer and closer to 0. It's going to do the same thing down here. It's going to get closer and closer to 0, but it's never going to actually touch 0. You can see as the numbers get bigger and bigger and bigger, as the x values get smaller, these y values get bigger and bigger and bigger. And so this is going to be a vertical asymptote. It's going to get closer and closer to 0 without ever touching 0. Vertical asymptote. It's going to cross the x-axis. X is going to be equal to 0. That's how they came up with the graph that is on your note paper. This graph that's over here on your note paper came from plotting the points and making the curve. You need to add this definition to your notes. An asymptote is a line that a curve approaches as it heads toward infinity. Infinity means it's getting bigger and bigger and bigger. And so this is our parent graph. Just like we've done on all of our parent graphs, now we're going to take this graph and we're going to move it up and down and left and right and stretch it and shrink it and also reflect it. Just like we've done before, if you have a number in here with the x, that's going to affect an x, but x is still a liar. If it says minus a number, it's going to go to the right. If it says x plus a number, it's going to go to the left. A positive k moves it up, a negative k moves it down. Well, what is it that I'm moving up and down and left and right? I'm moving this parent graph. So on my notes up here, this graph that's in blue, that's the parent graph. And it has an asymptote here, and it has an asymptote here, and that's what the parent graph looks like. So, where has this been moved? This one has been moved. So it has an asymptote here for the parent graph, and an asymptote here for my transformed graph. So it has moved left 3. The parent graph has an asymptote here. This new graph has an asymptote there, so it's been moved up 2. This graph right here, the one in blue here, is the parent graph, and so you can see that this has been flipped across the x-axis and it's flipped upside down. Okay, now I have drawn in for you in this light blue, that's the parent graph. So what's happened between this parent graph and that graph right there? It's been stretched, it's been pulled out. This a equals 2 makes it stretch. A equals 1/2 makes it shrink. This is the parent graph. This is the new graph. It's been pulled in closer. It has been shrunk. Let's do some examples. So, the parent graph has an asymptote here and here. This asymptote has been moved right 2. The parent graph has an asymptote here. This one's moved up 1, 2, 3, 4. Up 4. This is 2. This is 4, we'll talk about the A in a minute. The horizontal asymptote, this is the horizontal asymptote right here. HA stands for horizontal asymptote. It crosses the y-axis at 1, 2, 3, 4. The horizontal asymptote crosses the y-axis at 4. This is the vertical asymptote. The vertical asymptote crosses the x-axis at 2. See the relationship between these numbers and these numbers? Okay, so the rational function is this one right here. So g of x equals, we're going to come back to the a, 1 over x minus 2 plus 4. It's been moved right 2, but x is a liar, so it's minus 2, and up 4. Okay. Now, how do we find the a? The a, instead of being rise over run, is going to be rise times the run. So, on a parent graph from this asymptote, let's go back over here to our parent graph on our first page. Our parent graph has a key point at the point 1, 1. If from this asymptote you rise up 1 and go over 1, the a is equal to 1. Well, let's look over here on our example number 1. On our example number 1, I've got to find a pretty point here. This is a pretty point, and I rise up 1, 2, 3, and run over 1. A is equal to 3 times 1. The A is equal to 3. It's had a stretch of 3. The domain is all real numbers except the asymptote. The domain is all real numbers except x equals 2. I should say except. See if I can fit that in there. The range is all real numbers except the asymptote y equals 4. So it's all the real numbers except the asymptote. The asymptote is